people, how y'all doing? Today, well, same day, we're gonna be going over arrays. I'm just gonna go ahead into it, do just the main part. And so, on my second screen, I do have an array presentation from the prof. So I'm gonna try to cover what he's going through. So if I'm a little bit slow, sorry. All right. Now, arrays, the way they work, the way you initiate an array, you say the type of array you want to make. So whether it's an character array or an int array or a bool array, the type here is what the array is gonna hold. So I can say array, and inside here I'll put the size. So let's say I want a size 10. Now what does this mean? That means the array looks something like this. Well, it's empty, but let's assume it's like this 10 times. That's what it looks like. Okay. Now the other syntax of making an array is I can also say this equals, and I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? But I believe this one is curly if I can remember. Is this the right syntax? Yep. And now how can I print this and make sure that's right the syntax? Now when you work with an array, you can simply do just print out the array. And so let's see what this does. So now when I play this or run it, what do I get here? You see, I get just an address. Now, why is that? It's because the array actually acts like a pointer. So the way when you create an array, we'll go to my stack, right? We'll go to my stack, right? And so up here, I have my stack. And so in here, what it will do is it will take the first section that's open, and this will be indices 0. This is going to be index 9. Oh, there it is. There you go. This is going to be, wait, I think it's this one. Yeah, this is going to be index 0, right? And what it's going to make, it's going to make a pointer that points here. Okay, so then under it, whoops, under here, what I'm going to have is index number 1. Now in my 0, this is my position 0. So that would be 1, and this would be 2, right? Now how do I access my 2? One syntax is you put brackets, and here you put the indice. So indice 0 would give me 1. As you can see, they give me 1, and I can go 1, 2, 3, whoops, 3, 4, 5, and so on. Okay, that's one way to do it. Now another thing you should know about your array is, as you can see, we're in the stack. Okay, and so once you, well, one, you have to declare the size of this array. You have to, because this is in the stack. So once you declare it here, you can't change it. It's set in stone. You can change it's what's inside of it, yes. You can't change its size, however. All right. Now, can I make an empty array? No. You see, so it's telling you incomplete type int is not allowed. So you have to put some size. So I could put size 0. That's fine. I could access index 0. Let's see actually what happens here. Will this crash? It might give me a segmentation fault. So what it actually gave us is a garbage number. Now what this means is, obviously we have some indice here. So if I delete this, so obviously I do have my index 0, but it points to some random memory. Random memory. Oh, there you go. You see, it goes to some random memory. So this number was whatever was inside this random ass memory. Okay, and so that's really how you initiate arrays. That's how you can start them. how can you change things? So if I do this index is, let's make it hold 1, right? And then what I'm going to say is array at index 0. And I can change this to 5. And so now when I print it, this would be 5. Because I just changed whatever's at index 0. And you see now when I run it, this gives me 5. Okay? That's one way to do indices, or sorry, not indices, arrays. Now, another thing, remember how I said arrays are pointers to one index and it goes? Then when you do index 1, it actually goes to the next one. And they are stored one beside the other. One beside the other, okay? So can we treat this as an array? Yes, you actually can. So I could dereference this. And so if I dereference this, what it will give me is the first position is pointing to index 0. And so when I print this, index 0 is 5. Now, one thing I can also do is I can increment this. So I can tell this, go to the next address, this +1. It means whatever address you're at, go to the next one. Okay? And you see, so if this was size 2, and I'll make it equals to 5 and 3. Let's remove this line. You see now this is array which points to 5 because that's index 0. I'm doing +1, so it's going to go to 3. Then I'm going to dereference it. So if I don't, this will give me the address of 3 because it's a pointer. So if I dereference it, it will get me the address of the array. Oh, sorry, the value of the array. Right, and you see if I remove this, I do that, it gives me the address. Okay, and so that's really what it is. Arrays are pointers that point to the first line of the array, and then you can increment and go downwards either with brackets, or you can increment them like this and dereference them. And so if you watched the last lecture, can we create a pointer that points to this array? Yeah. So what I could say is I could make a pointer, right? And I'm going to make it equal to array, right? Now, is this valid? Let's see. If I dereference pointer, what will it give me? 5. And you see, this is valid. What I did is I gave it the address. Remember, this is a pointer. And so I made this pointer equals whatever address this is. One more way is I could also make it point to the first index. By default, it points to the first index. But obviously, you see this syntax gives me 5. So I want the address of 5. So I gotta get the address of 5. What is going on here? Invalid y. This is very valid. Let me see. What? I just initialized the pointer and it's giving me underscore. But I think my my compiler is tripping. Yeah, see, it works. So right now I have my pointer equals the address of index 0, which is this. And so if I increment, actually I don't know if it works like this or if I have to put them in brackets. Yeah, so what I did now, it's 5 plus 1. What I have to do is increment the pointer, then dereference it. And see, it works the same way. Now, can I make it point to 3 instead? Yeah. So now I'm just making a pointer point to this, and I can go from this to this because it's stored in the array one after the other, right? And so this is very possible. Now, another thing is that this is, like we said, is in the stack. So that means the size I make it here, this cannot change. Because when I run my program, the stack will be determined. And I'll be like, you know what, this is the space you have. I can't use more. For my whole program, it predetermines the stack for my program. It checks all the code, but you know what? For this code, you need, let's say, 10 spots. It puts me 10 spots in the stack, and that's all I can do. And so can I do an input and change this? So can I do, you know, like a send? So let's do here int size, let's equal it to 0, and then here, whoops, I'll determine size using an input, and then here I'll put size. So is this valid? Let's run it. So here let's do 10, and you see that works. Whoa. Let me try to access array. Well, let's get rid of that. Let's initialize it like this. Get rid of those. And so after I initialize it, what I'm gonna do, I'm gonna also input something. So right, so I'm gonna input something into the number, and then I'm gonna say is array. So I'm gonna choose for size 10. So that means at NDC 9, that should be fine. I'm gonna make something on my NDC 9 equals my number that I'm gonna put. And see, let's see if this works. So if I do 10, I do 10. You see, actually, oops, let's change this to 9. And 9, and you see now it prints 9. And so this passes through the stack. So you see, this works, but this actually isn't supposed to work. This doesn't work on every compiler. It's just the compiler I have it works on. But in a lot of compilers, this is not valid because this is in the stack. And since I'm depending on some input, the compiler cannot determine this at compile time. But obviously my compiler is weird. But this is actually not supposed to run. This is not standard C++. And so that's why I was like, why is it running? Well, apparently it's my compiler. So here, as you can see, the size depends on an input. But this is in the stack. The stack is predetermined. It's just mine is retarded. But you get the point. So now if I want to make it able to change sizes, I have to put it in the heap. The heap is something that's same as a stack. The box. That looks kind of good box. It's called a heap. And this shrinks and gets large in size. Alright? So you can access it, you can increase the array, you can decrease the array. Now how do I create a array in the heap? And so what else do? You can only point to the heap. You can only point to some position in the heap. I cannot do int array equals like somewhere in the heap. I can only point to it. And so I'm gonna make a pointer. I'm gonna make it equal what? So use new word. This new means put it in the heap. I'm gonna make a pointer that points somewhere in the heap. Now what am I putting in the heap? I can put an integer. This is just I just created space in the heap for an integer. Now if I put 2 brackets, I created space in the heap. Do I have to put size, I think? Yeah. Okay. So here I create space in the heap of type integer array of size 0. Now I can make this size 10. And so now what I made is I allocated 10 spots in the heap, and I made a pointer point to the top of it. Okay? So this pointer points to the top of my array. Okay? Now what I want to do, I can make this larger. So throughout my code, I could do now the input thing. So what I could do here, I could predetermine this. I can make this size, and I could do int size. I could do, and you see now this is predetermined, and this is completely fine, right? Now if I wanna make this larger, let's say I determined the size. I took an input. This becomes 10. So let's say this becomes 10. I took input. It became 10. Now what if this 10 spots get filled up and I want to make the array larger? What I can do, I can make a second input, right? So I'm going to make a second array of the new size. So let's say the new size is 20. So what I'll do here, I'll do a for loop. In this for loop, I'm going to go int I equals 0. So I'm just going to start from the beginning. And then I'm going to say is I less than 10. Because obviously I have 10 here. I just want it to run 10 times. And then I plus plus. Okay. So what I'm trying to what I'm trying to do here is I'm going to copy every section from here into here. Okay, so what I'm going to do is I'm going to go, okay, then this pointer points to the first section, right? And so pointer at pointer plus I. So first is going to be plus 0. So that would be this top section. Then it's going to be plus 2. And so that will be the second section. And then plus 3, third section, fourth section, and so on. Obviously, I want the value of this. And so what I'll do, dereference it. Now I got the value. Now I want whatever value is at this first spot to be equal to the first spot of this new array I created. So the first spot here, I want it to be here. What I'm trying to do is copy this, because I'm trying to make it larger. So I allocated 20 new spaces. I'm going to copy this into here and then delete this, right? And so I got the value at position 1, and this will loop, right? I want this to equal to the position of this. And so right, pointer 2 plus I. Same thing, equals pointer 1 plus I. Okay? And so this will loop, make index 1, index 0 equals index 0. Index 1 equals index 1. Index 2 equals index 2. And we'll copy this whole thing into here. And now down here, there's a word called delete. I'm going to delete my pointer array. I believe, yeah, I thought this was syntaxically wrong. So it was like this. And so now what I'm doing is I'm deleting an array. The name is pointer. Okay, so I'm deallocating. So now this memory that I took up, deallocated. It's freed up. It's very important to do this, because if you don't delete it, you'll keep allocating, then your heap will be full and your program will crash. So that's why we delete. Now if you only want to delete a pointer, if I have like this, equals new int. So obviously this is not an array. How do I delete it? You just do this. Without this, this says it's an array. Without it, you're just deleting a pointer in the heap. Okay. Now back to our lesson. And so now that I copied in and I deleted it, see, I now got bigger size. This was only possible because I can allocate more space in the heap. That's why. If this was in the stack, my program predetermines 5. How am I gonna enlarge this and make it 20? I can't. That's why I do it in the heap. Okay? And that's all there is in the heap. Now you saw how I did this whole thing, whole operation. It's a lot of syntax, a lot of things. There's a second easier way to do it. And it's a library called vectors. Now, how do vectors work? Vectors are same as arrays. It's a pointer. It's the same as arrays in the heap. So it's created in the heap, and there's a pointer that points to the top of it. Now the syntax for it, you just gotta remember the syntax. You want to say the type, which is vector. Right, I'm making a vector. I'm using this library, and you use std with it, by the way. Unless you're using this, you don't have to do this. Okay, but I don't like to use this, so I'm gonna use that. All right. Now, what's my second parameter? Is the type of array it is. So I'm making an integer vector. All right. And now here is the name of the vector. So I can name it vector. I can name it array. I can name it as. It doesn't matter. So we're gonna go array. Okay. Now I created this vector. How do I set things into this vector? So one way, I could do array dot push back, and I can push back whatever I want. Okay. So let's say I want to push back 5. This will push 5 into the top of my array. Sorry, the top of my vector. So let's say this is my heap. And so what I did is this is my vector. So actually, this is not my vector. My vector points to this first location. Okay, and my vector is of size 1. So when I'm gonna do push back 5, 5 will be here. Now if I do it again, what happens is your vector will automatically resize, and It's another 5. Automatically resizes, right? That's what makes vector so much easier to work with, is because you don't have to manually copy and do all that. And so you can, what do you call it? It automatically resizes itself. Now another thing, I want to pop something out. Pop, and I can pop whatever, 5. But for pop, this will only pop your top section. And so when I do this, this will pop me the top. Okay. What is going on here? Value void cannot be assigned to initialized entity of type int y. Oops. Let's see if this runs. Yeah. And so what this does is it pops up the top. Whatever is at the top, it pops it. Okay. So that's how the pop back works. For vectors, let me go through the slides and see what else he went through. Okay, so for vectors, if I want to go through a vector, use it same as array. So if I want to access it, same thing. I could do it at index 0. Let's make this 10. And you see, that gave me 5. And then if I do index 1, this should give me 10. Okay. And now if I pop back, why didn't this pop back? That's what I'm curious about. Again, for this, I have a weird compiler for some reason, but this pop back. So here I push this, and I push this on top, and I did pop back. This actually pops the 10. So when I'm trying to access the 1, the 10 is gone. So this is not supposed to happen. This will invoke weird behavior, and so this does pop back the most recent element. All right, it's just I have a weird compiler, unfortunately. Now, what if I want to iterate through my vector? How can I do that? So you see here, first I'm gonna actually array dot pushback. I'm gonna push back a couple things. Let's do 1. Oops. We're gonna do 1. Then we're gonna do 2. We're gonna do 3. And semicolon. Alright. Now, what if I want to loop through this? So what you could do one way is, since we know it's an integer type, I could say element in array. Right? So this is the syntax. What I'm saying is, for every element in this vector. Okay, so now my element will become index 1, then index 2, then index 3. Okay, so what I can do now is I can std right. And so when I print this, as you can see, it just loops through. That's one way to do it. Now there's one more way to do it. There's actually a couple more ways to do it. Now I could do auto. This works with C++11, which is allowed in Workshop, so this is fine. What this says is just, instead of me specifying int or string or class, I can just say auto, and this will decide on its own. Okay, and so what I'm doing is, what I want to do is iterate. This is an iterator equals vector. Well, would be array dot begin. All right, and then I'll do it does not equal, and I'll explain what this is. Int. Okay, and then I'll do it plus plus. Now what this one is, this is the iterator, I believe, if I'm not wrong. Yeah, so I just remembered actually. This is a pointer. And so what happens here, okay, so let me explain this from the beginning. What I'm doing here, I'm creating an auto, okay? Don't stress about this part, just keep as is. I'm just predetermining, I'm playing it figure out. But you see here, this is the type I'm returning. This whole thing is what my auto is. That's why I didn't want to specify, because this is not an int. This is not a string. This is something all on its own. It's a whole class library. That's why I just keep it as auto. Okay. Now I'm saying is it. It is a pointer iterator. It's an iterator. What I'm saying is this iterator, I want it to equal the beginning of my array. And I want this loop to keep going until I want it to keep going while the iterator is not at the end. Okay, so this iterator will go through the beginning, this second part, third part, fourth part, as long as it's not the end. And then I'm gonna plus plus. So I'm gonna move the iterator. And the iterator acts as a pointer. So what this is, we'll go index 0, index 1, index 2, we'll print it, and I'm like, oh, I'm at the end, done. And so when I print it, same thing. Okay, that's another way you can loop through a vector. Now vectors are the same as variables. So if I create a function void print vector, and what is it going to expect? It's going to expect the vector, right? So I believe I would do std vector array. So I'm expecting a array, right? A vector array. And so what I'm gonna have it do is just do the same thing I've been doing here. I'm just gonna move this, and so this will print my vector, right? So far so good. So now I'm gonna pass it this vector. So print vector array. Now this actually, if I run it, it runs, but I actually passed by value. So this made a new copy of this vector, and then it printed it. But you can also pass it by reference. So just like we did with variables, I put an address here, so I can tell it up here, I can tell it whatever array I put in here, take its address. So this is passing it by reference. Okay, as you know, when I run it, it still works the same, except this is now by reference, and I'm not making a copy. Do pay attention to this. You might bring it and you might slip, so please do make sure you understand what this is. All right, I'm basically passing an address and not a copy. Now, one last thing is, let's say I want to return a vector in here. Let's say I also want to do array at 0 equals 20. Okay, and so before we do anything, let's confirm what we learned earlier and see if this actually works. And oh, I actually wrote this in the wrong spot. And you see here, my vector at 0 is 1. I'm gonna try to change it to 20 and see if this will print 20 or 1. Does it change? Is it by reference or value? As you know, it's 20. But why did this print an extra 20? Oh, because of this. So yeah, so this ran, I printed 1, 2, 3, then I changed 20, and I printed it, then it printed 20. Now, what if I do this? And I run it. See, it printed 1 again, because I'm passing by value and not by reference. I'm not referring to this. I'm just passing a copy, right? And so that's that. Now, one more thing I wanted to go over, and that is, what if I wanted to return? So instead of me passing it by value, I'm going to pass it by reference, and I'm going to return this new part, right? And so how can I return array? I want to return this array. I changed this part, I want to return it. How can I do that? And the one way I do that is, instead of void, I'll put vector int, because the type of thing I'm returning is, well, I need my std. And so because what I'm returning is a vector of type int. So this takes what type you're returning. I'm returning vector type int. And so this is valid. Okay. So you see here, I could make this, I could do this, and well, you see I'm returning a vector, but I can't put it in an int. I have to put it in a vector. So I could say this works. Now if I want to access, so actually here, what if I want to print new array? You see the new array we returned, the first index is 20. So if we're equaling it, this also have to be 20. And we're gonna check. See, there you go. And that's really it for vectors.